How to debug Java memory corruption bugs. Imagine your Java application suddenly crashes or behaves unpredictably, and you have no idea why. Memory corruption bugs are tricky because they often hide deep within native code or the Java virtual machine itself. These bugs are rare but can cause serious issues like JVM crashes or data loss. Today, we will explore how to find and fix these elusive problems step by step. First, understand that in Java, memory corruption usually involves native memory outside the managed heap. This can happen when native code, such as Java native interface code, mismanages memory or when there are bugs in the JVM. Symptoms might include application crashes, segmentation faults, or strange behavior that is hard to reproduce. To start, you need to reproduce the problem consistently. Narrow down the code paths involved, especially those interacting with native code or using direct byte buffers. Once you can reproduce the issue, turn on JVM diagnostic tools. Use options like show message box on error and heap dump on out of memory errors to generate crash logs. Analyze the error files carefully for clues about native crashes or memory issues. Use verbose garbage collection logs to monitor heap behavior and rule out heap leaks. Next, analyze memory usage. Use Java profilers and memory analyzers to check for heap leaks or objects that stay around longer than they should. For native memory, tools like the command line utility jcmd can report native memory usage. If your application uses Java native interface, review the native code thoroughly. Look for buffer overflows, invalid pointers, or improper memory management. Use native debugging tools like Valgrind or AddressSanitizer on Linux systems to detect native memory errors. These tools can find issues like buffer overflows or use after-free errors. For more advanced detection, tools like Linaro Dynamic Debugging Tool can identify heap corruption, out-of-bounds writes, or double freeze. These tools can pause execution exactly where the memory misuse occurs. Remember that garbage collection does not cause memory corruption but tuning. It can help identify heap fragmentation or leaks that make problems worse. Use JVM monitoring tools to observe memory pools and garbage collector activity. Also, check that all native libraries and JNI wrappers are up to date and stable. Sometimes updating the JVM to the latest version can fix bugs that cause memory corruption. When debugging, start with JVM logs and heap analysis to rule out Java heap issues. If native memory is involved, switch to native debugging tools. Set breakpoints or watchpoints in native code to catch invalid memory operations. Add extensive logging around native calls to trace memory allocations and deallocations. To prevent future issues, avoid unsafe native code when possible. Use safer alternatives like Java native access libraries or well-tested native libraries. Regularly profile and monitor memory usage in both development and production environments. Implement automated tests that stress native interfaces to catch memory corruption early. Combining JVM diagnostic tools, native memory debuggers, and careful code review of native interactions will help you find and fix these bugs. With patience and the right tools, you can master debugging Java memory corruption bugs and keep your applications running smoothly.